This is problem number 8 in the QHack 2023 Quantum Coding Challenges, and it's entitled Stuck in the Middle with You. And in this problem, we're being asked to implement the following circuit where we have 4 qubits. We apply Hadamard gates to each of these qubits, then an RX gate, some CNOT gates. But the interesting part is that we're asked to perform a mid-circuit measurement of qubit 0 and qubit 2, and then use the results of those measurements to control a U3 gate. And the condition to control that U3 gate is that if the result of qubit 0 plus the result of qubit 2 is greater or equal to 1, then we should apply this gate. And if they're smaller than 1, then the gate shouldn't be applied. And then we apply just a Z gate, and then we just perform a measurement to get the probabilities on that last qubit. So one interesting thing about this condition is that when we do this addition modulo 2, this is equivalent to having at least one of these 2 qubits equal to 1. So it's like performing an OR operation, right? So if this is 0 and this is 1, then this will be applied. If this is 1 and this is 0, this will be applied. If this is 1 and 1, it will be applied. But if it's 0, 0, it won't be applied. So let's take a look and see how we can implement this in pennylane. So as always, we import pennylane as QML and numpy as MP. Let me make sure I run that cell. And then we're going to have a circuit with 4 qubits. So let's just go ahead and create our device and our Q node. We're going to call that circuit just circuit and pass some angles, right? And then we're just basically first going to apply Hadamard gates to all qubits. So we're going to use that broadcast function in pennylane, apply the Hadamard gate to all qubits using the pattern single. And then we have our RX gate on qubit 0 with the first angle in that list as the parameter, and then 2 CNOT gates. So let's make sure that we got this right. So we go here, we have RX gate, then CNOT from 0 to 3 and from 2 to 1. So 0, 3, 2 to 1, and then that RX gate on qubit 0 with angles, the first parameter on that angles. Now, the next step is to perform the mid-circuit measurements. So in pennylane, the way we can do this is we do QML measure, and we specify which qubit we want to measure. So we do qubits, so we do wires equals 0, and then QML measure wires equals 2, right? We're performing measurement on qubit 0 and qubit 2. But then we need to apply some conditional on that last U3 gate that depends on this output. So we're going to store these results in some variable. We can call it output 1 and output 2. And then we're told that the condition is that if these two, the sum of these two is greater or equal to 1, then we should apply that gate. So we can in pennylane, we can actually add these up just by using addition here, and it will be interpreted correctly. And then to apply that conditional gate, we use QML conditional, cond, and then first we pass the condition. So we said output must be greater or equal to 1, and then we pass the gate we want to apply. So that will be QML U3. And then since this is parameterized gate, we have to pass to the function that is returned by this conditional the parameters for this U3. So we do angles 1, angles 2, and angles 3, which are the 3 parameters that we need to pass to that U3. And then we need to specify on which wire we want to apply the U3 gate, and that's on wire 3, right? And then lastly, we're going to apply this QML poly Z on wire 3 as well, and our circuit has to return QML props only on wire 3, right? Okay, So then let's go ahead and first draw our circuit for this given angles. So let's do print QML draw circuit and pass those angles. And then let's also print the output of that circuit, right? So instead of doing QML draw, we're just gonna evaluate that circuit at angles, right? And then if we do this, first let's analyze this circuit. So we have our Holomarts at the input, the RX gate, the CX gates. And now take a look at this conditional for the U3 gate. So here we specify a mathematical equation for the condition, right? We said measure qubit 0, measure qubit 2, and then take the sum of those two. And then when the sum of those two is greater or equal to 1, apply that gate. And we said that this is equivalent to like an OR statement where if this is 0, 1, 1, 0, or 1, 1, that gate should be applied. And if you see here, pennylane interpreted that correctly. So we see here that this U3 gate gets applied if this qubit 0 is 0, or this qubit 2 is 1. This qubit 0 is 1 and qubit 2 is 0, or if qubit 0 is 1 and qubit 2 is 1. So this is like an OR statement for the application of this U3 gate depending on these two qubits. And then we have here the final Z gate applied and then measure the probabilities. And these angles I pass here are what's given to us as the test case in this problem. And if we see here, the output we're expecting is 0.799 and 0.2003. And here we can see that we get the correct output. So let me know if you have any questions, and see you in the next video.